covalent bond is where electrons are shared between two nonmetal atoms. Let's start with hydrogen, which is a nonmetal on the left side of the periodic table. Hydrogen has an atomic number equal to 1, which means that it has 1 proton and 1 electron. If we take two hydrogen atoms, each with its own electron, we can combine them to form a molecule, where each atom contributes 1 valence electron to the final molecule. In other words, these two valence electrons are shared by both atoms in the final molecule. We can represent this process by putting 2 dots between the 2 hydrogen atoms. These 2 dots represent 1 covalent bond. We can also represent a covalent bond by drawing a straight line between the hydrogen atoms. One straight line means 1 covalent bond and represents 2 valence electrons. Now, in our hydrogen molecule, opposite charges attract. So the 1 electron from the hydrogen atom on the left is attracted to the positively charged nucleus of the hydrogen atom on the right. At the same time, the negatively charged electron from the hydrogen on the right is attracted to the positively charged nucleus of the hydrogen on the left. So a mutual attractive force holds together the 2 atoms in the covalent bond. At the same time, like charges repel, which keeps the 2 positively charged nuclei from getting any closer together. Another way to represent the hydrogen molecule is by writing H with the subscript 2. This implies that we have 2 hydrogen atoms in our molecule. So hydrogen is an example of a diatomic molecule, which is a molecule composed of 2 atoms. There's an easy way to remember a list of the elements that form diatomic molecules. Imagine a mad scientist whose name is Dr. Brinkelhoff, whose name spells out each of the diatomic molecules. Br is bromine, I is iodine, N is nitrogen, Cl is chlorine, H is hydrogen, O is oxygen, and F is fluorine. Let's try drawing some of the structures of these molecules, starting with the example of the fluorine molecule, F2. Fluorine is in group 7A on the periodic table. Because the group number is equal to the number of valence electrons, we know that each fluorine atom has 7 valence electrons around it. Fluorine is most stable when it has a full set of 8 electrons around it, which is referred to as an octet. For this reason, it will tend to form bonds that allow it to get an octet of electrons. It gains an electron by sharing one of the 7 electrons from another fluorine atom to create a covalent bond. There are therefore 2 shared electrons in the covalent bond, one from each atom. Each fluorine atom in a diatomic fluorine molecule has a full octet, consisting of 7 electrons from its original set, and the 8th electron shared with the other neighboring fluorine atom. Now let's look at the oxygen molecule, O2. Oxygen is in group 6A on the periodic table, so each oxygen atom has 6 valence electrons. We can draw these in around each oxygen atom. We can see that we still don't have an octet around each oxygen atom, because each oxygen atom is missing 2 electrons from its octet. So to get an octet of electrons, the atoms need to share 4 electrons with one another. And that happens by having a double bond between the 2 oxygen atoms. We indicate a double bond with a double line in drawings of the molecule. Let's look at the nitrogen molecule, N2. Nitrogen is in group 5A on the periodic table, so each nitrogen has 5 valence electrons. And we can draw these in around each nitrogen atom. And once again, we can see that we still don't have an octet around each nitrogen atom because each nitrogen atom is missing 3 electrons from its octet. As a result, 2 nitrogen atoms will share 6 electrons with each other, resulting in a triple bond between the nitrogen atoms and an octet around each nitrogen. You can probably see where this is going, but we indicate a triple bond with a triple line in drawings of the molecule. Molecules don't have to be diatomic. For example, we can draw out the dot structure for methane, which has a chemical formula CH4. Carbon is in group 4A on the periodic table, so carbon has 4 valence electrons. We can draw these in around the carbon atom. Next, recall that hydrogen is in group 1A, so each hydrogen has 1 valence electron. Notice how the 4 hydrogens all fit around the central carbon to form 4 carbon-hydrogen bonds. Carbon is now surrounded by 8 electrons, resulting in an octet, and thus our final stable molecule. You should notice that hydrogen does not follow the octet rule. That's because the first period has a shell that holds a maximum of 2 electrons. Since hydrogen is in the first period, it is stable with only 2 electrons around it. Finally, we can look at water, which has a molecular formula of H2O, which means that it has 2 hydrogen atoms and 1 oxygen atom. We already know that hydrogen is in group 1A, and oxygen is in group 6A on the periodic table. So each oxygen has 6 valence electrons. We can draw these in around the oxygen atom. As before, each hydrogen has 1 valence electron. If we draw out the water molecule, then we can see how each hydrogen shares its electron with oxygen. The final dot structure shows that oxygen has an octet of electrons around it, and each hydrogen has 2. Alright, it's a quick recap. Covalent bonds form when nonmetal atoms share their valence electrons among themselves, in order to allow all the atoms to have a full octet. Hydrogen is one of the exceptions to the octet rule, because it ends up with only 2 electrons around it. Many elements such as oxygen, nitrogen, and hydrogen form diatomic molecules. In a water molecule, an oxygen atom gains an octet of electrons by sharing electrons with 2 hydrogen atoms.